We're told the Great Pyramid was built around 2560 BCE. That date appears in textbooks, documentaries, museums. It sounds remarkably precise, doesn't it? But that number isn't carved anywhere into the stone. There is simply no plaque to be found. No engraved timestamp exists within these walls. So where does that date actually come from? Is it based on inscriptions? Could it be ancient graffiti left behind? Is it based on modern radiocarbon testing? Or is the answer more complicated than that? Because stone itself cannot be radiocarbon dated. You can date wood, charcoal, organic remains. But the pyramid is limestone, so if the stone itself doesn't carry a time stamp, what exactly anchors 2560 BCE? Is the date direct evidence? Or an informed reconstruction? Is the discovery of Khufu's name really enough? Is the radiocarbon dating itself truly definitive? Or are we dealing with something more indirect? By the end of this video, you'll know exactly what supports the official date. And more importantly, how strong that support really is. The official timeline places the Great Pyramid in Egypt's 4th dynasty. This period is known as the Old Kingdom, a phase often described as the high point of early Egyptian state power. And at the center of that period stands one ruler. The reign of Pharaoh Khufu is traditionally dated to this era. According to mainstream Egyptology, the Great Pyramid was built as his tomb. Construction is typically dated to around 2560 BCE. That estimate is not arbitrary. It comes from a combination of historical records and archaeology. Ancient king lists preserve sequences of rulers. Khufu appears in those sequences, and historians estimate dates by calculating reign lengths backward from later anchors. These anchors include astronomical records and synchronisms with other civilizations. By the 4th dynasty, Egypt was already a centralized state. It had organized labor, taxation systems, and large-scale building experience. The Great Pyramid did not emerge from nothing. It followed earlier experiments in pyramid construction. So within the official model, its appearance fits a broader developmental arc. Placed in this context, 2560 BCE makes structural sense. A powerful king, a stable state, a progression of architectural experimentation. This is the mainstream position, and it is supported by multiple overlapping lines of evidence. Now we get to the single strongest piece of evidence tying the Great Pyramid to Khufu. Now we get to the single strongest piece of evidence tying the Great Pyramid to Khufu. Not a royal inscription on the outside, not a royal inscription on the outside, but marks found in spaces most people never see. But marks found in spaces most people never see. Above the king's chamber are narrow compartments called relieving chambers. Above the king's chamber are narrow compartments called relieving chambers. They weren't designed to be visited. They weren't designed to be visited. And on these stones, there are inscriptions painted in red ochre. And on these stones, there are inscriptions painted in red ochre. Some of these inscriptions explicitly include Khufu's name, marking his presence. Some of these inscriptions explicitly include Khufu's name, marking his presence. Khufu, also rendered as Khnum Khufu in some sources. Khufu, also rendered as Khnum Khufu in some sources. These aren't fancy carvings for propaganda. These aren't fancy carvings for propaganda. They look like functional labeling. They look like functional labeling. Some appear to reference work gangs, crew names. Some appear to reference work gangs, crew names. One of the famous examples is often translated as something like Friends of Khufu. One of the famous examples is often translated as something like Friends of Khufu. The idea is simple. Crews mark blocks as they move through the supply chain. The idea is simple. Crews mark blocks as they move through the supply chain. From the initial quarrying of the massive limestone blocks, to the arduous transport across the land and the Nile, and finally to their precise placement in the pyramid structure. And if those marks were applied during construction, And if those marks were applied during construction, they strongly connect the pyramid to Khufu's reign. They strongly connect the pyramid to Khufu's reign, which pulls the construction date into the 4th dynasty, This is why historians treat this evidence as strong. But here's the nuance. Graffiti isn't the same as a construction contract. It strongly suggests Khufu's administration was involved. But by itself, it doesn't answer every question about how the full dating picture is built. The Great Pyramid does not stand alone. Just south of the main complex, archaeologists uncovered a massive worker settlement. This site includes barracks-style housing, bakeries, and storage facilities. It wasn't a temporary camp. It reflects organized labor on a national scale. Large quantities of cattle bones suggest sustained provisioning. Estimates suggest thousands of workers rotated seasonally. Tools found nearby include copper chisels and stone pounders. Copper tools were used primarily for limestone shaping. For harder granite, dolerite pounding stones appeared to have been used. The limestone used for much of the pyramid was quarried directly from the plateau. In fact, parts of the quarry remain visible. Granite, however, came from Aswan, hundreds of kilometers to the south. The Nile provided a transport highway. This suggests coordination across regions, and importantly, the Great Pyramid follows earlier monumental projects. The bent pyramid shows structural experimentation. The red pyramid represents refinement. This progression aligns with Old Kingdom architectural evolution. So the Great Pyramid exists within a functioning cultural system. It fits into labor systems, tool technology, and political organization already in place. Nothing about its context suggests isolation from the Old Kingdom. This broader archaeological environment reinforces the conventional 4th dynasty date. So how do we scientifically date something made of stone? The first limitation is simple. Limestone cannot be radiocarbon dated. Radiocarbon dating works by measuring the decay of carbon-14 in organic material. The process works effectively on ancient wood samples. It can also date fragments of charcoal found at the site, and even on microscopic plant fibers or ancient rope, and critically, organic particles trapped inside mortar. When limestone blocks were set, mortar sometimes included small bits of organic material. Those fragments can be sampled and tested using accelerator mass spectrometry. Radiocarbon testing campaigns at Giza were conducted in the late 20th century. The results largely cluster around the Old Kingdom period. Many samples fall within a range roughly consistent with the traditional 4th dynasty date. But, and this matters, the dates are not a single number. Radiocarbon dates come with margins of error. Depending on the sample and calibration, uncertainty can range from decades to over a century, and some results appear slightly older than the expected reign of Khufu. This may reflect what researchers call the old wood effect. If old wood was reused in mortar or construction, it could yield an earlier radiocarbon date. Overall, the radiocarbon evidence does not contradict the Old Kingdom model. Radiocarbon dates cluster around the Old Kingdom, but with variation. And that variation is where interpretation begins. Radiocarbon dating is one of the most powerful tools in archaeology. But like any scientific method, it has limits. The first limitation is known as the old wood problem. Wood can live for hundreds of years before being cut. The inner rings are older than the outer rings. If ancient wood is reused in construction, It can produce a date older than the building itself. The second issue is reuse. In ancient societies, materials were often recycled. Charcoal fragments embedded in mortar may have already been decades or centuries old. The third major limitation we face is contamination. Over thousands of years, organic material can enter cracks. Modern labs attempt to remove contaminants, but elimination is never absolutely perfect. And finally, calibration. Carbon-14 levels in the atmosphere have fluctuated over time, so raw radiocarbon dates must be adjusted using calibration curves. These adjustments introduce ranges, not single-year precision. This is why carbon results are expressed as date ranges. Radiocarbon provides probability windows, not exact timestamps. This does not invalidate the Old Kingdom dating. It simply defines the level of certainty we're working with. A common claim is that the Great Pyramid appears fully formed, as if it emerged, without precedent. But that isn't how pyramid building began. Early elite tombs were mastabas, rectangular, flat-roofed structures built from mud brick and stone. They established the core concept, a monumental burial structure. Then came the step pyramid of Giza. In the Third Dynasty, architect Imhotep essentially stacked mastabas vertically. This was a structural leap, but not a finished solution. Next came the bent pyramid. Its changing angle reveals structural instability. During construction, the builders corrected their approach mid-project. Then the Red Pyramid, often considered the first true smooth-sided pyramid. Here the angle is stable. The geometry is controlled. By the time we reach Khufu's Great Pyramid, the engineering trajectory is clear. Mastaba, step pyramid, bent pyramid, red pyramid. This is a clear testament to gradual refinement. Precision improves, structural understanding deepens. The Great Pyramid is extraordinary, but it is not without ancestry. The story of the pyramid is a story of human evolution. Even if the timeline makes sense, one thing still hits people hard: precision. Because this structure isn't just big, it's controlled. To begin, let's start with alignment. The Great Pyramid is aligned extremely closely to true north. Not magnetic north, true north. That implies careful astronomical observation. One plausible method uses circumpolar stars to find the north-south axis. With a plumb line and repeated measurements, you can refine direction. Not a single guess, repetition. And now look at the precision of leveling. The base is remarkably level across hundreds of meters. A simple technique, using water as a level, can create a consistent reference line. Water doesn't care about status or myth. It finds level. Combine that with plumb bobs, straight edges, and measuring ropes, and you can standardize measurement at scale. Which brings us to capability. Copper tools can cut limestone effectively. For granite, pounding stones can shape and smooth. It's slow, it's labor-intensive, but it's feasible. This is where people make a mistake. Impressive does not mean impossible. With time, skilled surveyors, and repeated checks, precision can emerge without modern machines. The real question isn't whether they could achieve precision, it's how we connect that precision to the date. One of the most discussed challenges to the conventional timeline doesn't begin with the pyramid. It begins with the Sphinx, specifically with patterns of erosion visible on the enclosure walls. Some researchers argue these vertical weathering patterns resemble water erosion The claim is that significant rainfall would be required. They'd produce this kind of surface texture. North Africa did experience wetter periods thousands of years ago. The argument follows: if the erosion is from heavy rainfall, the Sphinx could predate the Old Kingdom, and possibly the surrounding complex could predate the Old Kingdom, and that would imply an earlier construction phase at Giza. Most geologists, however, disagree with that interpretation. They argue the erosion can be explained by differential weathering, wind, salt crystallization, and natural limestone variability can produce similar patterns. In other words, water is not the only plausible mechanism. Erosion analysis involves interpretation of surface features, and interpretation depends on assumptions about environmental history. So this debate centers not on whether erosion exists, but on what caused it, and what that cause implies for dating. It's important to note, this debate primarily concerns the Sphinx enclosure. It does not directly date the Great Pyramid itself. As of now, the majority geological view aligns with the conventional Old Kingdom chronology, but the existence of the debate illustrates something important. Even stone surfaces can become part of a larger dating conversation. One of the most discussed challenges to the conventional timeline doesn't begin with the pyramid. It begins with the Sphinx, specifically with patterns of erosion visible on the enclosure walls. Some researchers argue these vertical weathering patterns resemble water erosion. The claim is that significant rainfall would be required. They'd produce this kind of surface texture. North Africa did experience wetter periods thousands of years ago. The argument follows: if the erosion is from heavy rainfall, the Sphinx could predate the Old Kingdom, and possibly the surrounding complex could predate the Old Kingdom, and that would imply an earlier construction phase at Giza. Most geologists, however, disagree with that interpretation. They argue the erosion can be explained by differential weathering, wind, salt crystallization, and natural limestone variability can produce similar patterns. In other words, water is not the only plausible mechanism. Erosion analysis involves interpretation of surface features, and interpretation depends on assumptions about environmental history. So this debate centers not on whether erosion exists, but on what caused it, and what that cause implies for dating. It's important to note, this debate primarily concerns the Sphinx enclosure. It does not directly date the Great Pyramid itself. As of now, the majority geological view aligns with the conventional Old Kingdom chronology, but the existence of the debate illustrates something important. Even stone surfaces can become part of a larger dating conversation. Now let's do this properly. If the Great Pyramid were significantly older, 2,000 to 5,000 years older, then it wouldn't just change one date. It would change the entire surrounding world we should see in the evidence. So what would we expect to find? The first indicator to look for is cultural mismatch. If the pyramid were much older, the surrounding artifacts should not consistently align with Old Kingdom Egypt. The second key indicator involves the tools used. A much older construction would suggest either earlier versions of the same tool systems showing up in the same layers, or a completely different toolkit showing up in the same layers. The third indicator is stratigraphic anomalies. If a monument is truly older, it should sit in a clear stratigraphic context. You'd expect older layers beneath it, then later layers building on top. You'd expect older layers beneath it, then later layers building on top. Fourth, surrounding material culture. Pottery, burial customs, settlement patterns. These evolve over time. Pottery, burial customs, settlement patterns. These evolve over time. A pyramid thousands of years older would be surrounded by a different cultural footprint. In other words, an older date should leave an older footprint. So this is the test. Mismatch in culture, mismatch in tools, mismatch in layers, mismatch in material life. And that's why the question isn't, could it be older? It's, does the surrounding evidence behave like it's older? During the last ice age, sea levels were dramatically lower. At their lowest point, oceans stood roughly 120 meters below modern levels. That exposed vast coastal plains that are now underwater. These plains would have been attractive to early human populations. Food sources, freshwater access, trade routes. As ice melted, those landscapes were flooded. Today, archaeology struggles to access these submerged regions. This creates a genuine archaeological blind spot. But a blind spot is not evidence of advanced civilization. It is possible that coastal settlements were lost, but possibility alone does not establish probability. Possible does not mean probable. We do have evidence of increasingly complex societies before the Old Kingdom, but complexity is not the same as pyramid-scale stone engineering. If a global Ice Age civilization built at this level, we would expect broader, repeated traces across multiple regions, not a single isolated anomaly. The vast and ancient ocean still hides much from our view, and archaeology works by accumulating patterns until consistent material evidence appears that predates the Old Kingdom at this level of engineering. The underwater civilization argument remains an open possibility, but not the most probable explanation. When debates like this surface, another idea often appears. The idea of academic inertia, that scholars resist new interpretations to protect existing models. There is some truth here, but not in the way it's often framed. Paradigm shifts in science are rare. They happen when evidence becomes overwhelming, not when ideas are merely intriguing. Scientific consensus is not maintained by secret agreement. It is maintained by accumulated evidence. Claims are tested, replicated, challenged, and revised. And the larger the claim, the larger the evidence required. Extraordinary claims require extraordinary evidence. Redating the Great Pyramid thousands of years earlier would not be a minor adjustment. It would reshape multiple interconnected chronologies, Egyptian chronology, regional trade timelines, early agricultural development. That level of revision demands more than anomalies. It demands convergence of independent lines of evidence, geology, archaeology, material culture, stratigraphy. So skepticism toward dramatic reinterpretations is not automatically suppression. Scientific consensus is not a conspiracy. It is the current best model built from available evidence. And like all models, it remains open to change if the evidence justifies it. So where does this leave us? What actually dates the Great Pyramid? Worker inscriptions, archaeological context, radiocarbon samples, developmental sequence. Taken together, these lines of evidence converge on an Old Kingdom construction date, approximately 2560 BCE, during the reign of Khufu. Approximately 2560 BCE during the reign of Khufu. Right now, the evidence supports an Old Kingdom construction date. But there is no engraved timestamp. Carved into the core stones. The pyramid is not dated directly. The dating relies on context. It relies on inscriptions, like these found in the relieving chambers. Specifically, inscriptions like the Gang of Khufu cartouche. It relies on associated settlements and material culture. In other words, the date is built from indirect convergence. And when multiple independent lines of evidence align, that alignment carries weight. That weight at present supports the conventional chronology. That weight at present supports the conventional chronology, not because it is unquestionable, but because it is currently the strongest model, supported by available evidence. The Great Pyramid doesn't need to be older to be extraordinary. The Great Pyramid doesn't need to be older to be extraordinary. Its impact doesn't depend on rewriting history. Its impact doesn't depend on rewriting history. It depends on understanding it correctly. What makes it powerful is not mystery. What makes it powerful is not mystery. It is precision, absolute precision. It is precision, pure precision. Precision achieved with simple tools. Precision achieved with simple tools. Precision achieved through endless repetition. Precision achieved through constant repetition. Measured, checked, refined. And precision doesn't disappear into myth. And precision doesn't disappear into myth. And this precision leaves evidence. Clear physical evidence left by ancient tools. Archaeological inscriptions found at the site. Evidence of ancient worker settlements. Physical measurements taken from the stone, providing total archaeological context for the site. The story of the Great Pyramid is not weaker because it is grounded. The story of the Great Pyramid is not weaker because it is grounded. It's stronger, much stronger, and that raises a better question. If they used copper tools, how did they achieve that level of precision? How did they achieve that level of precision? Next, how did they achieve that precision with copper tools? Because that question deserves the same forensic treatment. Because that question deserves the same forensic treatment.